Now, for section 3.8, it's also about arguments, but this time we're going to use a different way of proving whether they're valid or invalid called Euler diagrams. So it looks like Euler, but the guy's name is actually pronounced Euler. And so this is how you use Euler diagrams. Now, basically, Euler just used Venn diagrams. So Euler diagrams look just like Venn diagrams. And you're going to make a diagram for the first premise. Then you're going to make a diagram for the second premise on top of the one for the first. The argument is valid if and only if every possible diagram illustrates the conclusion of the argument. If there is even one possible diagram that contradicts the conclusion, this indicates that the conclusion is not true in every case, so the argument is invalid. Now, I want to remind you guys of some of our Venn diagrams and how they translate to words. You did this a little bit already in some of the previous homework assignments. So you're going to mainly focus on Euler diagrams when all of your arguments are quantitative statements. Do you guys remember quantitative statements? All, some, or none. Okay? And so if you recall, this type of Venn diagram means that all A are B. So if you have a statement that's all A are B, you're putting the first item in a circle, and that circle goes inside the second circle for the second item. The next quantitative statement, when the circles don't touch, then this means you have a, what kind of, no, right, no A are B. They don't touch, no A are B. Nothing in common. Okay, no A are B. This would be some A are B, and we're talking about the intersection. So some R means you're talking about that part in the intersection. And the last possibility is that you have some A are not B. So notice we're focused on the other area of the overlapping circles. So some A are not B. So it's that portion that doesn't intersect with B. Yeah, the other one had an X in the gray section. Okay, so here would be our argument. All freshmen take history. Everyone who takes history takes chemistry. And therefore, all freshmen take chemistry. Sometimes there's only going to be one way that you can draw your diagram, and then you just determine whether it's valid or invalid. But really, your goal is to see if you can draw it in a way where it doesn't work. In other words, we're going back to that word from chapter 1 called counterexample. If you can just show one way it doesn't work, you know it's invalid. Okay, starting with the first sentence. All freshmen take history. So what's the key word there? All. And then we have two things that we're focused on in here. We're talking about freshmen and history. Okay, so you need a circle for freshmen and a circle for history. And how should those circles compare to each other? One inside the other, right. Which one should be on the inside? Freshmen. Always the first item. The first item, freshman, goes inside of the second one because all freshmen are the ones that are taking history. Okay, so I made a circle for freshmen and then a circle for takes history that goes around that circle. Okay, now we go to the second statement, and our key word, we have everyone who takes history takes chemistry. So what's the key word there? Everyone, which is the same as all. Okay, so then the two things that we're focused on are those who take history and then those who take chemistry. Now, we already have a circle for history, so now we need to make another circle for chemistry. And where do we need to place that circle? Around the history, right, because history has to go inside of chemistry. So we only had one choice there. So once you look at the first two premises, now you take a look at the conclusion. Sometimes you might have to make another circle in the conclusion. But in this case, we already have freshmen in chemistry taken care of. So it says, therefore, all freshmen take chemistry. This is the only way we could have drawn this picture. And is that true according to the picture? Yes. Freshmen are inside of chemistry, so therefore all freshmen must be taking chemistry as well. Let's take a look at number 20 real quick in section 3.8. Okay, it says all logic problems make sense. All logic problems make sense. So the key word there is all. So I need a circle for logic. Okay, so L is logic. And then I need a circle for sense. Okay, so S for sense. And where does that circle need to go? Around the logic. Okay, then the second one says some jokes make sense. Some jokes make sense. So I need, the key word here is some, and I need a circle for jokes, and I already have a circle for sense. Okay, so here's the thing. Before I draw my circle for joke, I want to take a peek at the conclusion, and I want to see if I can draw it in a way where the conclusion doesn't work. Okay, so it says some logical problems are jokes. So in other words, for this to work, the circle for jokes has to intersect the circle for logic. I don't want to make it work. So can I make the second sentence work without making the jokes hit the circle for logic? Yes, if I just draw it like this, notice I have some jokes make sense right here. There's overlapping. But this does not overlap with logic. And therefore, I have drawn it in a way that proves the conclusion false, and that's what makes this invalid. So it doesn't matter if you can draw it to make it work. I want you guys to try and draw it so that it doesn't work. And if you can do that, then it's invalid. Now, if it's impossible to draw it in a way to make it not work, then it's valid. Okay, so that's your challenge in these. Now, there are other videos in Math Excel, so I encourage you to take a look at those videos as well. And otherwise, the practice test is available